This is lesson number 74 in Algebra 1, having to do with scientific notation. Now, scientific notation you've done before, but just as a reminder, it's a shortcut method of writing very large numbers. And in science, you have to deal with a lot of very large numbers and very small numbers. So instead of writing something like 26, let's just put a whole bunch of zeros on here. A number like that, we can rewrite it in a shortcut method. And not only can we rewrite it in a shortcut method, but when we manipulate those numbers, let's say we multiplied that number by another number the same size. You can't put that in your calculator because most calculators only allow you to put 8 to 10 digits in there. And this is a lot more than that. So what you do is you come up with another method that will allow you to put huge numbers in your calculator and just kind of streamline things a little bit better. So there's actually two steps in order to rewrite these numbers in what's called scientific notation. The first step is to put a decimal right after the first non-zero number. So it will always go just to the right of the very first non-zero number. Okay, so that's for a number like that. But what if I had a number like this? Again, the decimal goes after the first non-zero number. So we ignore all these numbers here as far as putting the decimal. Alright, so let's get rid of this here. Alright, so let's just look at the top one for right now. So the decimal goes after that first non-zero number. So let's go ahead and blue and put a decimal there. And then we count how many places we moved that decimal. Alright, so in this particular one, the decimal doesn't exist. And if you remember, on any number, when it doesn't exist, it's always at the very, very end of the number. This one, it does exist, and we'll get to that in a minute. Alright, so the decimal actually is there, and we moved it there. Well, how many places did we move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we moved it 13 places. So what we're going to do is we're going to write this as 2.689, and since there's a whole bunch of zeros there, we're going to just throw those out. We don't need to list all the zeros. So once we start hitting a bunch of zeros at the end, we don't have to put those in there. So 2.689, then we're going to make a time sign and then a 10. And the number of digits that we move this will be our exponent. So what this says is we've got 2.689 times 10 to the 13th power. This number here means we move the decimal 13 places. Okay, so that's all that shows. So if we wanted to rewrite this in its original form, we would move this digit 13 places. Now, 13 to the left or 13 to the right? Well, the number 13 is positive here, and whenever you're dealing with number lines, the positive direction is always to the right. So if we wanted to go back to our original number, we would move this decimal right here, 13 to the positive, 13 positive, so 13 digits this way. Okay? So, since we want to make it scientific notation, we moved it 13 to the left. In order to get back to where it's supposed to be, we move it 13 back to the right. So that's what this positive 13 means, is this decimal's in the wrong place. In order to put it in the right place, we move it 13 in the positive direction. Okay, so let's look at the bottom one. We are going to first of all move our decimal after the 3. So it's going to become 3.248 times 10. And how many decimals did we move it? 1, 2, 3, 4, 5, 6, 7, 8. and that's going to give us an 8 there. Alright, so if we want to move the decimal back to where it's supposed to be, right now we put it here. Where is it supposed to be? Over here. We'd have to move it 8 to the left, 8 in the negative direction. Alright, so whenever we're looking at numbers, actually if we're converting a number to scientific notation, you follow those rules, but another way to look at it is if the number we're doing is bigger than 1, which this is. This is trillion, 26,890,000,000. That number is bigger than 1, therefore my exponent's positive. This number here is smaller than 1. There's no number over here. So when it's all decimals over here, then my number is very small, which means my exponent's going to be negative. Okay, so let's try a couple of these just to practice on. And let's see, get rid of this stuff. Oh my goodness. It's just not letting me get rid of. I don't understand this program. Alright. Let's look at an example like 0.000316. Now they're asking you to write that in scientific notation. So the first step is to put the decimal after the first non-zero digit. Then make a times and then a 10. Okay, now the number we moved it was 1, 2, 3, 4. We moved it 4 places. The hardest part is now whether or not that's a positive or a negative number. Okay, again, the way you determine that is if I want this decimal to go back in its original place, which way do I have to move it? I have to move it left. So that means it's a negative. And I'm done. If I have a number like 714,600, like that, again, first step, put the decimal there. Don't worry about all the zeros. And I moved it from here over to here. 1, 2, 3, 4, 5, 6, 7, 8. I moved it 8 places. So I'm going to put an 8 up here. And now I'm going to look and say, alright, it's there. How do I move it back to where it's supposed to be originally? I moved it to the right 8. So this number here stays positive. Alright? And that's my answer in scientific notation. Alright, so they give you a couple in here that are not necessarily tricky, but take a little bit more thought. Another procedure, because this one we have 0.0000316 times 10 to the minus 7, and they ask you to write that in scientific notation. Now a lot of people will look at that and say, well, it isn't scientific notation, it has times 10 to the negative 7. True, but the decimal's not in the right place. In order to be true scientific notation, the decimal has to go just to the right of the first non-zero number. So let's just kind of ignore that right now and write this part in true scientific notation. 3.16 times 10, and where did we move it? 1, 2, 3, 4. And to move it back to its original place, I'd have to go 4 to the left. So that means that would be negative. And we still have this here. So I'm just going to write it like that. Okay, so these are the ones that I'm going to look at in order to finish things up. And I'm just going to add these two together, and I'm done. Okay? So it's a pretty easy way when you have something weird like this, is you just kind of set that aside until the end, and then add the exponents, and you're done. Alright, so let's look at one like 0. Let's do it in blue. And let's make it to the positive 7. Let's write that in scientific notation. Okay, so we move the decimal over to 3.16. And how far did we move it over? 1, 2, 3, 4. We moved it over 4. And in order to get it back to where it's supposed to be, I'd have to move it 4 to the left, so that means that's negative. And then I also have my 10 to the 7th right there. Alright, so 3.16, and I'm going to add 4, negative 4 and 7. Negative 4 and 7 is going to be a positive 3. Okay? And that's it for that. Let's look at a couple more examples, and we can be done with this set of it just doesn't want to erase everything all at once. It drives me nutso. Okay, so 74.4. 47,800. Okay, first step, put the decimal there, get rid of the zeros, make that 10, and then count how many places I went over. I started there, 1, 2, 3, 4. So I've got a 4. In order to put this decimal back where it's supposed to be, I have to move 4 to the right. So 4 to the right, right is positive, so that's good. So that one's done. Alright, so if I have 47,800 times 10 to the minus 7, again, I'm going to write this as 4.78, get rid of the zeros, 10 to the, alright, so it was there, 1, 2, 3, 4. I moved it 4 over, so this is going to be a 4, and now I tag that on to the end. You don't even have to understand what that is. Add these together, and you're done. Alright, last one here. These out of there. Last one was 47,800 times 10 to the 7th. Okay, let's just look at these. Our decimal was there, we're going to move it there. So we're going to write it as 4.78 times 10. How many did we move it? 1, 2, 3, 4. And in order to put it back into this form, we had to move it to the right, so it's a positive. And that's there. So 4.78 times 10, 4 plus 7 is 11. And we're done. Okay, so that is it for lesson number 74.